Good evening. In this video, we will see what happens when the wind changes on our racecourse and what effects this has on us, depending on whether we are to the left or right side of the course. To understand this, we first need to know how we measure our distance from a mark when sailing upwind or downwind. Let's look at the example here and consider which boat is closer to Mark 1, the upwind mark. We have a green boat and a blue boat. We see that the green boat is nearly in a straight line with Mark 1, while the blue boat is more to the left of it. The question is, who will reach Mark 1 first? Who has a shorter distance to sail? Assume both boats are sailing at the same speed and tacking equally well. If we asked someone who isn't very knowledgeable about sailing, they'd say the green boat is closer in a straight line distance, while the blue boat is further away because it's more to the left. But that's not how things work in sailing, because we don't sail directly toward the mark, we sail at an angle to the wind. We can't sail in a straight line toward a point. We are forced to sail at angles into the wind and tack to change direction, essentially zigzagging to reach our destination. So let's look at how far the blue and green boats sail to reach Mark 1. In the first leg, they both start from the same point, our starting line. They each travel 2 squares forward and then tack. Both then travel the same number of squares to the next point. So from that point to the next, they both have sailed the same distance and each has done 1 tack. Now, looking above that line, we see the blue boat sails this light blue distance and the green sails a wider green distance. This forms an isosceles triangle, meaning those 2 sides are of equal length. In simpler terms, those 2 distances are the same. So from this point to the next, both boats sail the same distance. Then from there to Mark 1, the orange path is common to both boats. So, in this example, both the green and blue boats have effectively sailed the same distance to reach Mark 1. They each performed 2 tacks and traveled the exact same total distance. What does this tell us? It tells us it doesn't matter if we're more to the left or more to the right of the mark, as long as we're within the ley lines. Assume we are within the ley lines. So again, it doesn't matter how far left or right we are from the mark. What matters is our vertical distance to the mark relative to the wind direction. In other words, looking at the wind direction, I draw a perpendicular line and see how far I am from the mark. Whoever is closer to the mark along the wind axis has the advantage and will travel a shorter distance. In our example, both are exactly the same distance from Mark 1, so neither has the advantage. They will sail the same course and take the same time. Let's look at the animation in real time. They start. We see them cross the line together, having sailed the same distance. As they head up to Mark 1, they are still the same distance from it. I am referring to the distance relative to the wind direction, not the direct straight line distance. We continue. We see that they reach Mark 1 at the same time. They sailed the same distance and performed the same maneuvers. So no one had the advantage for being directly aligned with the mark or positioned more left or right. Again, this assumes they're within the ley lines and that the wind is consistent across the course. Now that we've seen this, let's look at a simpler way to measure distance to a mark. The classic method in sailing is to draw parallel lines that are perpendicular to the wind direction. These are called ladder rungs, like steps on a ladder. They let us see how much closer or farther each boat is compared to the others. Here I've drawn 2 rungs, and at this point, both boats are on the same step. Now we'll see what happens if the wind shifts to the left or the right, and whether someone gains or loses an advantage. Here's an image that clearly shows how ladder rungs work. We see Mark 1 in the wind direction, and we've drawn lines perpendicular to the wind. We count these rungs to see which boats are ahead or behind. We see all the boats are on the same rung, so no one is closer or farther in real sailing distance. All these boats, as in the earlier example, will travel the same distance to Mark 1. We're not considering how many tacks they need. Assume tacking takes no time. We are only evaluating who is advantaged by distance. We also look at their paths as static points, not their heading, but where they are now. Let's now see what happens when the wind shifts. In our example, this was the original wind direction. If the wind shifts to the right, the ley lines also shift. This means the starboard tack becomes more lifted, more favorable, while the port tack becomes less effective. If we were on the starboard tack, we'd feel like we're pointing higher. If we were on port, it would feel like we're headed straight into the wind. As the wind shifts, the ladder rungs rotate too. We see that now the boats are no longer on the same line. Each boat is on a different rung. We rotated the image to make this clearer. It's the same scene, just rotated to help us better see who has the advantage or disadvantage. The wind shifted to the right. This arrow shows the old wind. Now we align the new wind direction and we can see what happened. The boats are no longer on the same rungs. Some are higher, others lower. Some boats have overreached. We'll explain that shortly. For example, the green boat that was more to the left is now at a disadvantage, while the blue boat, which was more to the right, now has the advantage. So when the wind shifts to the right, boats on the right side of the course suddenly find themselves closer to the top mark. We also see that the yellow boat ends up right on the ley line and is almost 3 ladder steps ahead off the blue boat. However, a boat that was close to the ley line now finds itself overreached. It's closer to the mark but has overshot the optimal path. To put it simply, when the wind shifts right, boats on the right side gain an advantage. They are closer to the mark. Boats on the left side lose out. They are farther from the mark. Boats near the middle see little to no change. In the previous image, the red boat was on step 9. After the wind shift, it's still around 9, slightly lower, but not significantly changed. What does this tell us? It tells us that choosing to race all the way left or all the way right carries risk. You might gain a big advantage, or you might lose a lot. Sailing near the edges is high risk. Sailing down the middle is safer. Playing it safe means I choose a course that lets me sail both left and right, e.g., sail left, tack once, and aim for the lay line near the middle of the course. Taking a risk means committing to one side, sailing all the way left, tacking near the corner to reach the mark directly, or going all the way right and riding the starboard tack to the mark. So, to repeat, when the wind shifts to the right, boats on the right side are favored upwind. Boats on the left side lose out. When the wind shifts to the left, the reverse is true. This does notably the same way downwind. Downwind. Let's assume we're looking at this image again. Let's forget about the upward course and assume these boats are sailing downwind and the wind shifts to the right. We see the boat to the left is now lower. Let's look at it in a straight view. Now suppose these boats are going downwind and the wind shifts right. Then the boat on the right ends up higher, which would be good for upwind. But since we're going downwind, that boat is farther from the bottom mark, and the one on the left is closer. So again, when the wind shifts in a direction, say, right, then on upwind legs, boats on the right gain, but on downwind legs, boats on the right lose out, and the left side is closer. Let's see this in animation, in real time, what happens when the wind shifts. In this example, up to this point the wind is steady. From here on, the wind shifts to the left. Let's see if and how much the blue boat, which is further left, benefits from the leftward shift, compared to the green boat on the right. They start. Up to this point nothing changes. They are equally distant from Mark 1. Now the wind shifts. We rotate the image to immediately see the advantage. As soon as the wind shifts left, the blue boat is higher than the green, immediately closer to Mark 1. Continuing the animation, we see that the blue boat gained an advantage and arrives at Mark 1 earlier. It benefited from the wind shift. So we understand that if the blue boat knew the wind would shift to the left halfway up the course, it could choose to stay more left to take advantage. Indeed, the blue sailed more left and tacked near Mark 1 to benefit from the wind shift and gain an advantage. A good sailor who checks the course can identify wind shifts and use them strategically. To conclude, this is a very useful tool and one we must be familiar with. However, we must never forget the basic principles of racing. Sail simply. Think simply. Don't forget about speed and strategy. Make a good start. Sail fast. Sail the lifted tack, your favored course. Sail the side that takes you more upwind to the mark, and sail where there's more wind. That's all from me. Good evening.